I'm going to be playing this Kahoot game just as a review for you if you are not going to be here in class. This will be a review that you can refer to before you take the test. Which of the following is not an example of kinetic motion energy? So it was a book sitting on the shelf. So our options are a book sitting on the shelf, a rolling ball, or running. Okay, so kinetic energy is motion energy. So a rolling ball is moving. If you're running, you're moving. So those are both kinetic energy. So a book just sitting on a shelf does not have kinetic energy. It actually has gravitational potential energy. Look, I'm winning. All right, question number 2. How is this image transforming energy? So we have a trampoline. Is it chemical energy to radiant, sound to gravitational, or elastic potential energy to kinetic energy? So it is elastic potential energy to kinetic energy. Okay, so as the trampoline is stretched downwards, okay, it's elastic, it has the potential to throw the person back up in the air, which causes motion, okay, or kinetic energy. So it is elastic potential energy to kinetic energy. Okay, remember chemical energy is the things of like fuels, so like food or burning coal or gasoline. Radiant energy is light. Okay, there's no light being produced here on the trampoline. And then sound energy and gravitational energy, for the most part, there's no sound being produced, and the sound does not create gravitational energy. Question number 3, how is this image transforming energy? So we have burning wood. So is it chemical energy to radiant, kinetic energy to gravitational, or sound energy to nuclear? So it is chemical energy to radiant energy. So remember, anytime we have any kind of fuel or we're burning something, it's chemical energy, and then it's being converted to radiant energy or light energy. It could have also said thermal here as well, because it does produce heat. Okay, remember, kinetic energy is movement to gravitational energy is just being above the ground. So here the fire was on ground, so it's not creating more gravitational energy. Then here, sound and nuclear energy, it's very, very hard to produce nuclear energy. The only thing that really produces nuclear energy are like supernovas of stars. Question number 4, how is this image transforming energy? So we have a toaster. Is it radiant energy to sound energy, electric to thermal, or gravitational to electric? So it is electric to thermal. Okay, so we plug in the toaster and it gets hot, or it produces heat. So this is the most correct one. Question number 5. If the matter inside a substance is moving around rapidly, it will have a higher temperature or lower temperature. So it is higher temperature. So just like you, if you're running around rapidly, you're going to get more hot. Same thing with particles that make up substances. Question number 6. In what direction does heat flow naturally? Okay, so does it go from high to low or low to high? So it does go from high to low. So if you think about your hand being on the desk, your heat is transferring to the desktop. Okay, it's not that the desktop is pushing the coldness onto you. Question number 7. A hot cup of tea will cool off faster than a hot pitcher of tea due to lower thermal energy because of less mass, one being liquid, one being solid, or the temperature of the cup of tea is hotter. So it is less mass. Okay, they're both liquids, so this cannot be the correct answer, right? Because they're both tea, liquid tea. And for this one, the temperature of the cup being hotter, it never said that in the actual question, but also if the tea was hotter, it would cool off slower, just depending. So it has to do with the mass of the substance. Question number 8. What causes a partially inflated balloon to swell and eventually pop when held over a heat source? Is it thermal contraction, specific heat, or thermal expansion? So it is thermal expansion. So it is swelling up, it's expanding out because it's heating up, so it's thermal expansion. Contraction is things like how I talked about your tire pressure going down. Where your tire loses its tire pressure, that's due to thermal contraction, and it's slowing down whenever it's super cold outside. And specific heat has something completely different. Question number 9. What type of heat transfer is this? And so we see this cycle going through here where we have warm air and the cool breeze. And so it is convection because it's making that convection current going in a circle. What type of heat transfer is this photo? Okay, we have the mantle where we have the arrows going up, cycling around, and then going back down towards the center of the earth. This is also convection. Okay, so the molten iron heats up at the bottom. It rises near the Earth's crust, and then once it cools down, it goes back down towards the center again to heat up. Question 11, what type of heat transfer is this picture? And so the handle of the spoon is hot, even though it's not in the liquid, because of conduction. Okay, so even though the handle of the spoon is not in the hot coffee, okay, it's still warm to the touch because of conduction. Last question. What type of heat transfer does this image show? We have a heat lamp and a person feeling the heat from the heat lamp, and this is due to radiation. Okay, so the person is not directly touching the heat lamp, which would be conduction. Okay, and then the person is actually below the heat source. So remember, hot air rises, and so he's still feeling the heat even though he's below the heat lamp, and this is due to radiation. Okay, there are 3 other questions on the test, and they have to do with calculating kinetic energy, which is 1/2 mass times the velocity squared. Right, so you just have to plug those values into the equation. I have 1 question about finding gravitational potential energy. So you take the mass times the height times the acceleration of gravity, which is 9.8. And then the last one, math question that I have on there is about specific heat. So remember, that's mass times the specific heat times the change in temperature. Now, for the practice problems and the notes for the change of temperature, I had you actually have to calculate it out. On the test, I'll give you what the change of temperature is, okay? So you just have to multiply the 3 numbers together to find the specific heat.